Hello everyone, I am Kiran Kumar from Nature of Physics. In this video, we are discussing about the formulas from the all the first year chapters step by step, clearly going to explain with the diagram and small derivation and all the formulas. Please do like and subscribe our channel Nature of Physics and comment about video and share to your friends. See student, first vector. In this, position of the vector and unit vector formulas given, and then 2D vector is there. In the 2D vector, horizontal component, vertical component, along with the magnitude and direction of the 2D vector is given. And next one, equilibrium position, simple pendulum, clear derivation is including diagram is there. And 3D vector, in which cos square alpha plus cos square beta plus cos square gamma is equal to 1, and also parallelogram law of vector, in which magnitude of the vector and direction of the vector is given, and also Lamy's theorem and scalar product, in which formula and properties and also examples clearly given. And next one, that is vector product or scalar product and also their properties and formula along with the examples I gave you clearly. Next chapter is motion in a straight line. In motion in a straight line, first speed, that is average speed, next instantaneous speed formulas I gave you, and continuation, velocity formula and average velocity, instantaneous velocity clearly I gave you. And next one is average speed, that is 2 equal distance and 3 equal distance covered by the body also I gave you. And there is a clear relation between the distance and displacement, and speed and velocity also is there clearly on the screen. And also there is a relation between the speed and time and also displacement, and graphs also I gave you. And also next, acceleration, average acceleration, and also a relation between the acceleration, velocity and displacement, and graphs, clear diagrams I gave you. Okay, body at rest, uniform motion of the body, and next one is uniform motion, that is uniform acceleration and also constant acceleration, and uniform retardation motion and uniform retardation in opposite also I gave you clearly on the screen. And uniform acceleration, two graphs I gave you. Okay, that is constant acceleration and constant velocity. And then next one, kinematics formulas. First, one dimension given, that is freely falling body, and all the derivation formulas I gave you clearly, you can observe on the screen. And also next, properties, final velocity and nth distance traveled by the freely falling body. And after that, vertically upward projection body, clear diagram, maximum height, time of ascent and time of descent, and total time, time of flight, and initial velocity, final velocity, both are equal in magnitude, opposite in direction I gave you. And vertically upward projection body from the top of the tower, and that is displacement equation, net displacement, maximum height formulas I gave you clearly, final velocity, time taken to reach bottom also I gave you. And also there is a relation between the freely falling body, vertically downward thrown body, and also vertically upward projection body. For that, T1, T2, T3, clear relations, formulas I gave you. And next one is 2D motion, that is projectile motion, so in which projectile diagram and derivation formulas I gave you. And after this, maximum height and also time of ascent, time of flight, horizontal range. After this, next page we will discuss a relation between the maximum height and horizontal range, and also maximum height and time of flight. Then continuation, next one is clearly A is the tan theta, B is equal G divided by 2 U square cos square theta based on that relations given. And also here phi is the angle of elevation clearly given in the diagram, and formulas also is there, tan phi which is equal to 1 by 2 tan theta, and also displacement average formulas given from the projectile motion, and also final velocities, different cases also I gave you clearly on the screen, you can notice, and also continuation, horizontal range, and angular momentum, torque acting on the projectile, and radius of curvature also clearly gave. And next, vertically upward projection from the top of the tower, after that projectile motion on the top of the tower, and there is a difference between the range and r dash is also range given, r dash relation clearly I gave. And projectile motion on the inclined plane, that is from the bottom to top, range formula gave you time period, and also from the top to bottom also clearly given time period and horizontal range, including one diagram. And next one is horizontal projection from the top of the tower, sorry I did mistake there, here given horizontal projection from the top of the tower, and clearly T is equal root over 2h by g, and direction magnitude equation, horizontal range equations given, and also velocity at the bottom point also clearly given, relations alpha beta angles. Next, 2D motion in which boat and river concept formulas, including one dimension and also two dimension given. Student, see there, one dimension downstream and upstream, and also two dimension boat and river concept. VBR is the velocity of the boat with respect to river, and VBR resolve into two component. Based on that we will get the horizontal component and vertical component, and also drift and time taken to cross the river, conditions to reach the minimum time, and opposite bank, and also shortest path applications are there, in which first one is minimum time to reach the boat given, and also del given there, del is the deviation angle, and also boat crossing the river in the shortest distance also clearly given there, relations and formulas. And next one is there is a information about the VBG, velocity of the boat with respect to ground, and their last one is minimum drift on the opposite bank also clearly given, x minimum formula. Okay, very useful formulas, please share to your friends. And next, rain and umbrella concept. Student, rain and umbrella, VRM is the velocity of rain with respect to man, relation relative velocity formulas given, and also four cases are there. So first case in which, okay, so that rain is falling vertically downward direction given, and case 2, case 3, case 4 given, rain is making an angle theta slant with the vertical, and also man is speed up. Different three cases are there, clear diagram and formulas given for better understanding. Okay, and then next one is after rain and umbrella we will discuss about the laws of motion. See student, in the laws of motion, first momentum formulas I gave you, change in momentum also I gave you, and also continuation Newton laws of motion, so their relations given. And before that, change in momentum formula I gave you student. Okay, ball is projected horizontally to the wall, and Newton second law formulas I gave you, units and dimensions also I gave you student, only units. And then impulse diagram and impulse graph and impulse formulas clearly, impulse. Then finally we got the rocket also, net force acting on the rocket, downward direction weight, and thrust acting upward direction, perfect formulas given from the rocket. Okay, so that different formulas for the rocket I gave you student, velocity of the rocket, and also instantaneous velocity clearly given, and also finally different formulas I gave you for the rocket. Okay student, and also these all PDF short videos I will provide in the description also. Next one, friction formulas, static friction. Okay, and relations also I gave you, static friction diagrams also I gave you, and next one is kinetic friction. Before that, maximum static friction is called limiting friction, that is also given, and continuation rolling friction, including everywhere diagram and small concept to initial derivation, after that formulas, and static friction greater than to kinetic friction and greater than to the rolling friction, coefficient of static friction greater than to coefficient of kinetic friction greater than to coefficient of rolling friction, motion of a body on the horizontal rough surface also clear given. Total 5 cases are there, student. Clear derivation, we have the numerical based on this. This is very useful for the NEET and also mains exam purpose and other competitive exam purpose also. A block is sliding on the rough horizontal surface applications I gave you, and hemispherical bowl, and a block is fixed to a wall, so friction acting normal reaction applications also I gave you. Next one is angle of friction. See there, angle of friction formula tan phi is equal to mu derivation diagram given, and next angle of repose tan alpha, which is equal to mu s I gave you. Alpha is the angle of repose, and then applications also given. Okay, body move down on the smooth inclined plane, time period, velocity, acceleration, and a body move up on the smooth inclined plane, acceleration, initial velocity, time also I gave you, and a block is placed on the truck, so that we are getting the pseudo force opposite direction to the motion of the vehicle, and also applications I gave you clearly, time and displacement. So observer outside the road also I gave you. For example, a vehicle is moving on the front portion, a block is stopped on the mirror, that condition also acceleration I gave you, and chain on a table, and small l is the length of the chain hanging on the table, application coefficient of friction relations I gave you, and also a pulling land roller and also pushing land roller clearly I gave you, student. And then continuation, next one is applications, that is pulling force and pushing force on the blocks on the horizontal and also on the inclined plane given, stick a body with the roller also clearly given, coefficient of friction we got, and also angular velocity, and block on block 2 cases are there, student. Okay, force on the bottom block and also force on the top block also clearly given. Different cases, acceleration of the upper block and acceleration of the bottom block. And then next one is apparent weight of the person in the lift also given, lift at rest and uniform motion, and lift moving upward direction and lift moving downward direction, and freely falling lift also clearly given in that derivation. See, notice that. You can hold the video and you can read the formulas also, and connecting bodies formulas I gave you, and contact bodies also I gave you clearly, 2 blocks and 3 blocks derivations in which normal force, and that is, and in the connecting bodies tension also. And next one is Atwood Mission formula, most important formula, thrust on the pulley also I gave you, student, and different cases. Okay, so 2 blocks, okay, 3 blocks are connecting on the table, two are hanging, another one is on the table, and 2 blocks concept, one is vertically downward direction and another one is on the inclined plane. Everywhere we are going to find the tension, acceleration. If 2 tensions are there, different tensions also we are getting, most useful formulas. And also a block is connecting with a pulley and connecting to the rigid support, and acceleration of the pulley and acceleration of the block relations I gave you, and constrained motion clear derivation with including diagram I gave you, different cases also I gave you, student. Okay, so that here rate of change of displacement is called velocity, rate of change of velocity is called acceleration. Okay, so different velocity resolve into 2 component, based on that different diagram derivation Related formulas I gave you, very useful formulas. Constraint motion I gave you, student. Basic formulas I gave you. So already I said you relation between the displacement, velocity, acceleration, constraint motion diagram I gave you, and this is a little bit lengthy. Application formula also I gave you, so that you can easily understand the remaining formulas, and derivation problems also. Circular motion, that is theta is the angular displacement, omega is the angular velocity, and a relation also given, student, and alpha is the angular acceleration. Here also given average and also instantaneous velocity acceleration relations and units also. V is equal to r omega, very useful formula. Okay, and AC is the centripetal acceleration, AT is the tangential acceleration given. AC AT relation, FT FC relation, clear diagram derivations I gave you, student. Next one is conical pendulum also is there. So conical pendulum applications, tan theta is equal V square by RG, and also banking of road, circular turning of a vehicle on the road by the friction. First I gave you V is less than or equal to mu gr. Next, by banking of road only I gave you V is equal root over gr tan theta I gave you, student, and also two conditions are there. Okay, so case one is skid down, student. Next one is skid up I gave you, student. So skid down, I got the minimum velocity formula I gave you, including diagram. Everywhere diagram proof only I gave you. You can easily understand comparing to other. Okay, and next one also maximum velocity I gave you in the two cases by friction and also banking of road. Next topic is work energy and power. Okay, work applications, work formula, work diagram, units, and also different cases. So that theta 0, theta 90, theta 180 cases, and also a body is lifted certain height, there work done by the potential energy. Okay, and work done 0 also I gave you, and also potential energy, kinetic energy formulas I gave you, student, and conditions also I gave you, student. And there is a power formulas. Okay, rate of doing work is called power time graph, and work time graph clearly given, and different equations of the power also clearly I gave you. Almost 10 formulas I gave you. Notice that, student, on the screen. And next one is work done by the variable force also I gave you, and different work done examples I gave you, student. Okay, and a rod is, okay, so vertically suspended rod is pulled by the external force, center of mass will be changed. Work done by the different cases also clearly given in this diagram. And next one is relation between the momentum P and kinetic energy. Kinetic energy is equal to P square divided by 2m, and different conditions also I gave you relations. Change in the potential energy I gave you formulas, very useful formulas these. And also elastic potential energy of the spring, F is equal to minus kx. Potential energy of the spring is U is equal to half kx square, and also graphs given, student. Okay, so here the relation between the kinetic energy, velocity graphs also there, and vertical circular motion. This is very useful concept, and clear diagram and perfect diagram based formulas I gave you, especially velocity at the lowest position and also highest position, and tension also lowest position, highest position at any point, and different cases also given. Theta is equal to 0 degrees, theta is equal to 90, theta 180, theta 60 degrees, and velocity different positions also clearly given in the vertical circular motion. See, notice that, very useful formulas. And next one is collision. Given. And next one is ballistic pendulum. Okay, initial velocity, final velocity, change in kinetic energy clearly given, and oblique collision in 2D plane also 3-4 example diagrams I gave you perfectly one by one. Okay, velocity resolved along the horizontal direction and also vertical direction, and velocity along the horizontal direction and velocity along the vertical direction, and also kinetic energy before the collision, after the collision, step by step clearly I gave you. And a ball on a flat surface, case 1 given, and with respect to coefficient of restitution, case 2 also given, and next case 3 also given, student. So very useful formulas for the JEE mains and also NEET exam and other competitive exam also. In one shot you can easily understand like this formulas. Okay, in the exam time we will not have any time to refer all the books. Like this video if you watch, you will get clarity on the formula, student. Okay, and also velocity equation, change in momentum, and fraction of kinetic energy related formulas given. And next one is rotational motion. Okay, position of the two bodies. With respect to two bodies we got one center of mass position, so distance from center of mass to first body, second body, and center of mass of the x coordinate, center of mass of the y coordinates, and also center of mass of position vector, center of mass of the velocity and momentum, and also acceleration, and also net force formula, and center of mass of earth moon system also clearly given in this video. Okay, see student, and addition of mass and removal of mass, so that center of mass change, that shifting of center of mass I gave you, and disk of radius given smaller and shift in the center of mass and removal of mass, and also solid sphere of radius smaller is removed from the capital R radius sphere. That is also we have formulas, and also two disk R1 R2 radius and their combination center of mass, and two spheres R1 and R2 combination. And this is also very useful. A man is moving from one end of boat to the another end of the boat, so there is a shift in the center of mass, and also x0 is the displacement moving of center of mass, and there is a velocity clearly I gave you, displacement of the man, velocity of the man with respect to ground also clearly perfectly we have in this. And block on block also clear perfect diagram, and also basic 4 flanks I gave you based on that formulas. For 2 and 3 also I gave you. And moment of inertia I is equal to mr square, and moment of inertia, okay, individual particle, system of particle I gave you clearly, radius of gyration, and rotational kinetic energy rotational kinetic energy formula I gave you, and total energy, that is translational kinetic energy and rotational kinetic energy I gave you. Parallel axis theorem, perpendicular axis theorem also I gave you on the screen, student. Okay, these all are related to the moment of inertia of the ring, moment of inertia of the disc. Okay, and different cases also I gave you, a ring from the center, a ring from the tangential, and about any diameter of the ring given. So for the ring initially from the center mr square, and disc is mr square divided by 2, tangent perpendicular to the plane I gave you, and also next one is about any diameter, fourth case I gave you, tangent in its plane, third case I gave you. So all are related to each other. Hollow cylinder, moment of inertia, and also solid cylinder, different cases I gave you perfectly. Very useful formula, student. Please comment about my video, and please share to your friends this video, so that please like the video, then only the video will reach to the different number of students. It will reach the maximum number of student. Okay, and solid cylinder also clearly I gave you moment of inertia. And then continuation, next one is spherical shell I gave you, so that spherical shell 2 by 3 mr square, and solid sphere is 2 by 5 mr square, student. Okay, and solid sphere also 2 cases I gave you perfectly. Okay, and next one is moment of inertia of the rod with respect to center is IC is equal to ml square by 2, ml square by 12, and also moment of inertia at the end point given, and rectangular plate given, that is I is equal to m of l square plus b square divided by 12, and also moment of inertia of square plate. So different cases also I gave you three formulas about the square plane, and also torque formula, torque diagram and torque definition also I gave you, and also different cases torque is equal, okay, dl by dt. L is the angular momentum, and power relations also clear given. Power is equal tau omega given. Omega is the angular velocity, and couple acting on the system also clearly given, and balancing equations also clearly given, and rigid body in the equilibrium also given, student, a rigid body, okay. And also next one is continuation. There is a angular momentum diagram definition and formulas, different cases and torque formula, and two diagrams given about this. And next one, law of conservation of angular momentum also I gave you clearly in this, okay. I omega is equal to constant, and different cases also I gave you. dA by dt is equal to L by 2m, okay. And next toppling also including diagram, three diagrams given. This is very clear, you can easily find the different values also according to the question. And rolling motion given, first one is horizontal, okay, so that there is a two velocities are there, one is translation, another one is rotational, that is equal to rolling motion. So velocity at the lowest point, highest point, right side and left side, clear diagram and derivation proof also there about this. And uniform pure rolling motion also I gave you, okay. So in this velocity relation I gave you, and after that non-uniform pure rolling motion also I gave you with respect to acceleration relation given, student. AC is the center of mass of acceleration, okay. And then continuation, total energy of the rolling body in the translation motion I gave you. So already I said you, translation motion plus rotational motion is equal to rolling motion. So kinetic energy relation, and most important, that is equal to a rolling body on the inclined plane, rough inclined plane, frictional force also. Very good, very clear formulas we have. Acceleration formula, and also time taken by body to reach the bottom, and like a cylinder or sphere example taken, and also velocity of the body reach the ground on the inclined plane. And also next one is time period after friction formula I gave you, and coefficient of friction also. So almost relation formulas step by step clearly I gave you. You can easily understand, small idea on the concept. And oscillations, this is also very clearly given, horizontal and vertical displacement, and also velocity, mean position, extreme position, and also acceleration, mean position, extreme position, different conditions. SHM is, so A directly proportional to minus x, A directly proportional to minus y. In one shot I gave you everything detailedly in the diagram derivation proofs also somewhere I gave you, student. And also clear graphs we have, and also there is a equation of simple harmonic motion and time period on the horizontal vertical clearly given, and also kinetic energy, okay. So velocity is replaced in the simple harmonic motion, potential energy and total energy also I gave you, mean position, extreme position at any point, even graph also I gave you, potential energy and kinetic energy. And simple pendulum, okay, only diagram, formulas given. Time period T is directly proportional to root L, and time period T is inversely proportional to root G. And different cases also given. The initial phase I gave you, student, case 1, case 2, case 3, different equations. These are very useful, mains and advanced level I gave you, maximum with proof only, not written directly formula, student. A diagram based only we got the formulas, okay. Then next one, here we got the equation theta is equal phi sine omega t plus alpha. This is the angular displacement equation I got. Based on that we got the kinetic energy, potential energy, total energy. Energy neither be created nor be destroyed, total energy remains constant. And loaded spring also I gave you, and frequency, time period of the loaded spring. Capital M is the mass of the spring, included formula I gave you. and relation between the K is the force constant or spring constant and L is the length of the spring. K inversely proportional to the length of the spring, and cutting of spring and K1, K2, L1, L2 related formulas I gave you perfectly, and also series combination of the spring, time period, and parallel combination of spring, time period also I gave you, and torsional pendulum and physical pendulum, time period, angular velocity formulas clearly on the screen, student. And oscillating U tube also given, okay, time period frequency equations I gave you, and test tube in a liquid given, and floating cylinder on the water also given, position in a cylinder also clearly given, a ball in the neck air chamber also clearly given, like a specific gravity bottle, time period. And next one is gravitation formulas. First we have the Kepler laws. In this also I gave you E is the eccentricity and relation RA and RP, okay, aphelion position and perihelion position, okay. VP is the velocity of perihelion, VA is the velocity of aphelion, and clearly law of area. First one is law of orbit, okay, and dA by dt is equal to L by 2m relation. Kepler third law, T square directly proportional to the A cube, or T square directly proportional to R cube, including formula proof also I gave you. Newton's law of gravitational force I gave you, and G is the universal gravitational constant, G value also I gave you. G experimental value formula also I gave you clearly, including values, okay, student. Relation between small g and capital G, G is equal to gm by r square I gave you, G is equal 4 by 3 pi g rho r also perfectly with proof I gave you, student. And variation of acceleration due to gravity with altitude, that is height, and with depth gd given formulas. And also there is a graph clearly given, GH and GD related formulas. And also then continuation, next one is latitude given, variation of acceleration due to gravity with latitude, G phi is equal G minus R omega square cos square phi. And equator pole cases and relation including time period also given, student. And gravitational field null point clearly given, null point x is equal to r divided by m2 by m1 plus 1 only. And gravitational field, gravitational force of the ring formula I gave you, circular disc also I gave you, student. And also spherical shell, okay. So that clear information step by step written and given for my hard work, okay. Please like and subscribe and comment about my video, and please share this video to your friends also, very useful to short preparation time. So one of the short video, that is 51 minute video we are getting, so easy for short time preparation for JEE mains and NEET purpose. And gravitational potential energy and potential difference given, and gravitational potential energy formula, basic formula I gave you clearly, student, okay. And potential energy of two particles also given, student. So on the surface at a height given, and at the center also given, and different cases also clearly given, at a height minus surface, okay, on the a body on the surface. And escape velocity, clear formula, escape velocity VE is equal root over 2gr, escape velocity value, orbital velocity formula, and value also I gave you 7.92 kilometer per second. Relation also I gave you, student. And time period frequency relation also I gave you. And next one, angular momentum also I gave you, student. Angular momentum L is equal to r bar cross p bar, that is L is equal to mv naught r. And the ratio of potential energy, kinetic energy, total energy, and also bending energy formula I gave you, student, clearly about the gravitational, kinetic energy, potential energy, total energy graph also given clearly on the screen. And here So a body is falling and a satellite is revolving around the earth in circular shape and also in elliptical shape and also parabola and hyperbola conditions based on the orbital velocity and escape velocity relation. Clear diagram I gave you. Hope you can easily understand this. And next one is mechanical properties of solids, in which stress, type of stress, and basic formula. Strain I gave you directly. Okay, change in length to the original length and Hooke's law and Young modules also I gave you. So y, which is equal to longitudinal stress by longitudinal strain, and different cases also I gave you, student. Relation between the force, length, and also area, and also elongation of the wire, and also two rods in series combination, two rods in parallel combination. Formulas also I gave you, series and parallel combination. Elongation of the rod due to its own weight. Clear diagram and formula I gave you. And next one, rigidity module. Okay, and rigidity module, one of the example also I gave you, student. After that we will get the bulk modules represented by letter K, rigidity modules represented by letter neta. So compressibility reciprocal of bulk module, and also continuation Poisson ratio, and there are four relation formulas given: sigma, Young module, bulk module, and rigidity module. And strain energy or elastic potential energy, different formulas with respect to stress, strain, and Young modules also clearly given there. Strain energy also I gave you with respect to stress and strain, and thermal force relations clearly given there, student. Okay, thermal stress, thermal related clearly we have. And also applications also given, student. Torsion of a cylinder I gave you one. And next one is fluid statics, in which, okay, pressure formula I gave you. After that, pressure variation of a cylinder in a water or liquid given, and Pascal law applications, gauge pressure given, student. Barometer formula also given, and also means a liquid fill in the U-shaped tube, and Pascal law, different cases, hydraulic lift. Okay, and specific gravity also given. Apparent weight, which is equal to weight into 1 minus 1 divided by specific gravity I gave you. And fluid dynamics next, okay, in which volume flow rate I gave you, and also mass flow rate, and equation of continuity, critical velocity. Here, student, Bernoulli theorem formula and different cases of Bernoulli theorem, different formulas also I gave you clearly on the screen. And horizontal pipe and Magnus effect formula also I gave you. Magnus effect, velocity is maximum at the top and minimum at the bottom. Okay, that's why pressure is maximum at the bottom, pressure is minimum at the top. And also there is a Venturi meter formulas, and before that clear relation formulas given in the fluid dynamics. Okay, and next one is Venturi meter velocity formula. We got v1 is equal to root over 2 into rho m gh divided by rho into capital A by small a whole square minus 1 whole to the power of minus 1 by 2. Viscosity formula, viscosity definition related, velocity gradient, and Newton's viscosity formula. Neta is the coefficient of viscosity, units, CGS units is Poisson relation also clearly I gave you. Coefficient of kinematic viscosity also I gave you, including formula and units and dimension clearly. Effect of pressure given, student, and Poisson formula. Okay, and capillarity tube step by step clearly I gave you. See, student, diagram derivation related formulas I gave you, very useful formulas, again and again repeating. Okay, try to understand. For my hard work, just I am expecting from you one like and subscribe and comment, and also share to your friends. Very useful. Terminal velocity also given based on the viscosity formula. Vt is equal to by 9 r square. Okay, related formula given, and also continuation. Okay, long screen, all the videos related also given, student, and surface tension formula. Okay, Surface tension also, every application clearly given, basic formula of surface tension, and also example of a rod, and also disc, and also ring, and also glass plates. Okay, and also related to the circular loop and disc and ring. Okay, so very useful formulas about the surface tension given for you. Okay, rectangular plate, a rectangular loop. Okay, and next one is surface energy. We will get, student, surface energy, work divided by area, so indirectly which is equal to surface tension only. So work done to blowing air bubble, soap bubble. Okay, and soap bubble formula is 8 pi r square t, air bubble is 4 pi r square t, and uh, work done to form area of the circular liquid given, and a big liquid drop convert into 2 or 3 or more different small droplets. Work done is given, and also 2 3 4 5 up to n liquid drops combined to form a big liquid drop. Capital R is the radius. There is a work done clearly given. And finally, angle of contact by the capillarity tube. So different equations for the surface tension also clearly given. Okay, mg is equal to pi r into t cos theta clearly given, student. And surface tension rho g h divided by 2 given, and two cases also given, student. Theta less than 90 degrees, theta greater than to 90 degrees. And next one is thermal expansion, and before that thermometry and Celsius scale, Kelvin scale, Fahrenheit. Okay, different scale formulas given, student. And also relation scale minus lower fixed point divided by upper fixed point minus lower fixed point is equal to scale. So Celsius scale, Fahrenheit scale relation also clearly given. Principle of thermometry for the constant pressure and constant volume also given. And thermal expansion of solid, alpha is the coefficient of linear expansion, beta is the coefficient of aerial expansion, gamma is the coefficient of volume expansion. Relation alpha, beta, gamma clearly given in one short video, student. And also continuation, change in length by original length into 100% with respect to coefficient of linear expansion, change in temperature, and with respect to L is equal to I omega, E is the moment of inertia, omega is the angular velocity. Perfect formulas, maximum proof also I gave you. You can easily understand, not given directly formula, student. And pendulum clock formula also, time period formula, change in time period also, with respect to error also I gave you, student. And then continuation, next one is grid iron pendulum also I gave you, student. Only one thing has missed, that is error formulas, unit sign, measurements, dimension formula, student. Almost all the topics has covered in this video. And bimetallic strip and radius also clearly given. And expansion of the liquids, that is apparent expansion, real expansion, expansion of the glass. Gamma r is equal gamma g plus gamma a, relations perfectly given including diagram, student. Okay, gamma r, gamma a, and also there is a gamma a formula, mass of the expelled liquid. Okay, and continuation formula given, student. And also relation with respect to density also given. Gamma r represent the coefficient of volume expansion of real expansion of the liquid, and density relation with respect to, okay, gamma is given. And next one is calorimetry formulas. So calorimetry also almost relation, specific heat formula, and also continuation Joule's law also given, student. And specific heat units, S is equal 1 by m delta Q divided by delta T. Okay na. And heat capacity or thermal capacity given. Okay, and mechanical equivalent of heat also, related formulas perfectly I gave you, student. And latent heat of fusion and latent heat of vaporization formulas. Okay, constant values also clearly given. Next one is expansion of gases. Okay, formulas. So that expansion of gases including diagram, normal temperature, high temperature. In water bath I gave you gas got expansion. And also Boyle's law, Charles law at constant pressure, and also Charles law at constant volume clearly given. Okay, Charles second law, that is volume constant. And next one is ideal gas equation. R is the universal gas constant. Pressure, volume, temperature relations clearly given. Okay, ideal gas equation in terms of Boltzmann constant. K is the Boltzmann constant. Okay, Na is the Avogadro number constant value also given. Next, Charles law, P is equal constant, a relation is given, graphs also given, continuation from the ideal gas equation. Student, these graphs are very useful graphs I gave you, student. Density and also force, pressure and density, temperature, density and volume related graphs are given. Basic, okay, formulas including derivation proof. Okay, and next one is thermodynamics. Student, first law of thermodynamics, molar specific heat at constant pressure and at constant volume, Cp greater than to Cv, Cp minus Cv is equal capital R. And different relation, all related formulas perfectly I gave you, student. Internal energy, so that is with respect to kinetic energy and potential energy. Okay, and also applications given clearly. Okay, so mechanical energy convert into heat energy related applications clearly is there. And isobaric process, so isobaric process graph given, work done is equal clearly given. And isochoric process given, student, here volume constant. Okay, and dv is equal 0, dw is equal 0 clearly given. Next, isothermal process given, student, work done by the isothermal process with respect to volume relation, pressure relation. And also K is the bulk modules related to the pressure clearly given from the isothermal process. And next one is adiabatic process. So adiabatic process, work done, PV to the power of gamma, TV to the power of gamma minus 1. And third relation also I gave you, and based on the graph we got the relation between the K bulk module and also pressure, student, that is equal to K, which is equal to gamma P I gave you, student. And isothermal and adiabatic curves also, four relations given, expansion and also compression. So isothermal process and adiabatic process perfectly work done, and also volume and also temperature related clearly given, student. Please do like and subscribe our channel Nature of Physics. And third one also clearly given, that is next fourth also completed, heat engine and refrigerator, Carnot engine related also given, student. Neta is the, okay, beta is the performance of the refrigerator given, neta is the efficiency of the Carnot engine given, student. And next one is KTG formulas, and KTG also including a diagram, derivation proof, RMS velocities clearly given one by one. Okay, so first I gave you diagram and pressure related to the volume, and finally we got the VRMS. VRMS is root mean square, pressure is equal to 1 by 3. Okay, n small m v divided by v square. V is the RMS velocity. RMS velocity equations also perfectly given with respect to capital R and also K. Okay, related formula also I gave you clearly. Kinetic energy is directly proportional to temperature, and R constant value, Boltzmann constant values clearly given. Okay, most probable speed and root mean square speed formula also, basic formula I gave you, student. Average speed with respect to RMS. Okay, RMS speed is greater than to the average speed is greater than to the most probable speed. And mean free path definition, different formulas also clearly written and given on the screen. Notice that, student. And transmission of heat is the last chapter. In transmission of heat also, Q is the heat is flowing from the lower temperature area to higher temperature area. Q by T is the rate of heat flow, temperature gradient clearly given. Okay, K is the coefficient of thermal conductivity, SI units, CGS units, and dimension formula also I gave you. And next one is thermal resistance formula, proof based on the diagram I gave you, student. Thermal resistance units also I gave you, and temperature at the junction of the two substance also clearly given, student. And also series combination, okay, effective resistance. Okay, coefficient of thermal conductivity related formulas also clearly given. After that, parallel combination of the slabs and coefficient of thermal conductivity parallel combination also step by step clearly given, and also applications also clearly given, student. And then next one is we are going to discuss about the thickness of the ice layer on the ponds in the cold countries. Also formulas, two formulas including formula explanation is given, student, and emissive power and Wien's displacement law and Stephen law emissivity also clearly given, student. And then continuation, next one is, that is Newton's law of cooling also we have. Okay, before that, that is Kirchhoff law given, student, and Stephen Boltzmann law also clearly given, student. And then continuation, next one is Newton's law of cooling only. Okay, so in the Newton law of cooling, the rate of loss of heat energy of a hot body given, student. Oh, Stephen Boltzmann law applications also is there before the Newton's law of cooling. Now we got Newton law of cooling, that is minus dq by dt directly proportional to theta minus theta naught. Rate of loss of heat energy of hot body is directly proportional to the temperature difference between system and surrounding. Theta naught represent the temperature of the surrounding, theta 1 initial temperature, theta 2 final temperature also we can clearly find based on this derivation. Please do like and subscribe our channel Nature of Physics.